Hi, welcome to the Lintas Technology Solutions Day 2021. My name is Diane, Senior Consulting Engineer in the Juniper Apex Solutions engineering team. In this session, we'll look at what Juniper is doing in this emerging and exciting area of Open RAN, in particular, the RAN Intelligent Controller, and why this is the key to unlocking the true potential of O-RAN for 5G. If you have any questions during this presentation, please input them into the comment box in your screen so that we can follow up with you. No Time to Die. That's the title of the latest James Bond movie. It's one of the most anticipated films of the year. Its release had been delayed by 18 months due to the COVID-19 pandemic. And it's Daniel Craig's fifth and final appearance as a famous British Secret Service agent 007. Fans go to James Bond movies for the romance, the action, and the amazing fast cars, like the iconic Aston Martin DB5 you see here. In fact, Aston Martin uses Juniper switching solutions at its data center, offices, and manufacturing sites. And what's a James Bond movie without Q's cool gadgets, like the glider submarine, the electromagnetic pulse watch, and the QDAR or QDAR, which maps out the architecture of the villain Safin's chemical plant and tracks the movements of the 007 agents inside the facility. One interesting fun fact about Q is that it's actually a job title rather than a name. Q stands for Quartermaster, the person in charge of supplies and provisions in the army. Q is probably the most underrated character in the Bond films. During the scene when Bond and Nomi infiltrates Safin's headquarters, he was the brains behind the brawn, the eye in the sky, guiding Bond and Nomi's movements and giving them situational awareness deep inside hostile enemy territory. What Q does for Bond is an apt analogy of what the RAN Intelligent Controller, or the RIC, does for the RAN, as we'll see in the next few slides. We'll first take a look at what is the role of the RIC in O-RAN, then illustrate through a use case how the RIC unlocks the true value of O-RAN for 5G. You may also be wondering, what has Juniper got to do with the RIC? We'll answer that question and provide an overview of Juniper's other 5G solutions in the end-to-end O-RAN mobile architecture. O-RAN is a fusion of the virtualized RAN and Open RAN principles. Basically, maximize the use of COTS hardware and merchant silicon and minimize proprietary hardware, and also standardize the disaggregated RAN architecture with a set of open, well-defined interfaces. But the unique aspect that O-RAN introduces to the RAN architecture is the concept of an open IAI-ML-based centralized controller, which is the RIC. In current RAN deployments, most of the control functionalities reside in the RAN components itself, GNOP, BBU, CUDU, etc. In the O-RAN architecture, that control functionality is extracted out of the CUDU into the RIC. Just like Q with the QDAR gadget, the RIC has global situational awareness for more coordinated, centralized control of RAN resources. And with AI/ML technologies, make more intelligent, more automated decisions. The real game changer is that now the control point to the RAN is open up, no longer locked to individual RAN suppliers. This creates a more diverse, more innovative, more competitive ecosystem of application providers. Although the RIC is still being standardized at O-RAN, the Juniper RIC solution is already in lab and field trials at Vodafone. It is a multi-vendor setup. Parallel wireless provided via virtualized BBU, HATNet gateway, and element management system. And this is integrated to the Juniper RIC through the O-RAN E2 interface. For this trial, the use case is to be able to extract the 4G core emission control function from the vRAN to an application running on the centralized RIC platform. And as you can see, the RIC and O-RAN architecture is applicable to 4G as much as it is so for 5G, so long as a software-driven radio can provide the necessary O-RAN interfaces to interwork with the RIC. So what exactly is a RIC? It's essentially the open, intelligent, and programmable brain of the software-driven RAN, just like what Q is to James Bond. The RIC solution consists of two components, the non-real-time RIC and the near real-time RIC. Both are fully compliant with O-RAN specifications, supporting open interfaces for multi-vendor interoperability. Both are also open platforms, able to host apps from third-party providers, RApps on the non-RT RIC and XApps on the near RT RIC. These third-party apps can be from traditional providers or non-traditional providers such as companies in the automotive or industrial robotics sector. The non-RT RIC typically resides at the central cloud of the operator, and one or more near RT RICs sit at the edge, nearer to the RAN elements. There are three major distinctions between these two components. The first has to do with the interfaces and the interactions. The non-real-time RIC connects to the near real-time RIC using the A1 interface to provide policies and guidance and to receive policy feedback. It is only the near real-time RIC that has direct control of the RAN elements, the CUs and DUs, through the E2 interface. The second distinction is the control loop. That's basically the time within which the RIC needs to complete the action it wants to undertake. For the non-real-time RIC, the control loop is typically 1 second or more. And for the near real-time RIC, it is usually between 10 milliseconds to 1 second. That's why it's called near real-time. The third major distinction is that AI ML model training and inference is done only at the non-real-time RIC. This is due to the longer control loop times, the availability of long-term and other enrichment data, and greater compute resources available to support such work. Let's use an example to discuss what's the problem with today's RAN architecture and how the RIC solves this. The example here is RAN slice SLA assurance. We'll start with a simple analogy to describe the problem. Suppose you own a premium personalized travel company. You have a tie-up with Golden Bird to offer priority airport transfer services for your VIP clients. The SLA is that Golden Bird will guarantee immediate availability of 10 limousines per day. There are 2 airports in the scheme, so Golden Bird statically standbys 5 limousines at Jakarta International Airport and 5 at Bali International Airport. The problem is that on a peak business travel day, for example, a weekday or during a major conference in Jakarta, 8 of your VIP clients arrive at Jakarta and 2 at Bali. The number is within the SLA with Golden Bird, but you still end up with 3 unhappy VIP clients. And on peak leisure travel days, for example, weekends or major holidays like Christmas, the reverse happens, and you have 3 unhappy VIP clients at Bali. A similar problem happens in RAN slice SLA assurance. The airports represent different G-Node Bs, and the VIP clients are the mobile users in a VIP slice. For example, a URL-LLC slice of a private network for a hospital campus. radio resource parameters like throughput and physical resource blocks or PRBs are statically assigned and separately managed by each GNode B. A surge in critical cases in a particular building of the hospital campus will cause a shift of URLLC demands to a particular GNode B. The GNode B hits the statically assigned quota for the URLLC slice and starts dropping excess traffic. At the same time, the quota in the other GNode B is underutilized. Add in more GNode Bs, small cells, and multiple tracking areas to the mix, and this problem of RAN slice SLA assurance becomes extremely complex. Let's see how this problem is solved in a RIC architecture. The RAN slice assurance RAP at the non-real-time RIC continuously monitors the current slice usage for the private network VIP slice by collecting slice-specific performance matrix. Now, there's a usage surge at one of the cell sites. The quota for the VIP slice is reached, excess traffic is dropped. The RAP analyzes that there's an SLA violation, even though the aggregate usage across all cell sites is still within the overall quota. The RAP immediately initiates corrective action by making appropriate slice-specific configuration changes and updating the policy on the RAN slice assurance XApp at the near real-time RIC, basically shifting some quota from underutilized cell sites to the overloaded one. The XApp takes care of propagating the configuration changes to the appropriate CUs and DUs. The XApp monitors the changes and sends back acknowledgements to the RAP to confirm that the slice usage and utilization levels are now meeting the specified SLA levels. To see the full demo of this use case, please visit this URL at the top of the screen. At this point in time, you might be wondering, what is Juniper doing in this RIC business? Why Juniper as O-RAN RIC? At the beginning of this year, Juniper announced an exclusive global licensing deal with a company called Netsia. Netsia is a pioneer in Open RAN and 5G. They've been developing an open, interoperable, best-in-class RIC platform for the past 5 years, with several proof-of-concept trials with major service providers already done, including the Vodafone example with parallel wireless that was shared earlier. The source code, patents, and technical domain experts have been transferred to Juniper, including more than 25 key patents related to the RIC platform, accepts RAPs, NSSMF, and so on. Juniper continues to innovate on this solid foundation by leveraging key Juniper technologies like the Marvis AI engine, recognized as a Gartner Magic Quadrant leader, to forge an AI-driven service experience for the RIC. Last but not least, Juniper is focused on driving open, interoperable industry standards, actively contributing to 6 of the 10 working groups in the O-RAN Alliance, including the overall architecture, the RIC, and the transport working groups. This is one of the questions in the quiz later, so let me repeat again. Juniper has active contributions to 6 of the 10 working groups in O-RAN. We talked about how the RIC is key to unlocking the true potential of O-RAN for 5G. It is a game changer for open innovation and multi-vendor automation of the RAN. And Juniper, with our best-in-class RIC platform, can help you succeed in your transformation journey of the RAN. And when we look at the extended end-to-end O-RAN architecture, Juniper also offers automation solutions for 5G transport and cloud applications. Automation solutions that are multi-vendor, cloud-native, and AI/ML driven, And through our innovative approach of low-code workflow automation and intent-based networking, we make automation accessible and easy to consume. In addition to 5G automation, Juniper also offers 5G solutions in the transport, cloud, and security spaces. Carrier class IP transport, that is the bread and butter of Juniper, starting from access with 10 and 25 gig to high-density 400 gig core routing platforms. Class B and Class C timing and synchronization support all across the network, advanced traffic engineering, and rich QoS capabilities. All critical ingredients for 5G transport and network slicing. Juniper also provides high-performance cloud fabrics, from 5G edge cloud to scale-out core cloud environments, with open, automated fabric management to truly simplify multi-vendor operations. And finally, connected security everywhere to secure your end-to-end 5G infrastructure. Juniper offers physical, virtualized, and containerized IPsec gateways, firewalls, and CGNet solutions. And to safely handle the incoming 5G traffic avalanche, Juniper offers a revolutionary, high-volume, yet super cost-effective DDoS mitigation solution. And these network operators like you choose Juniper to help them deliver real business outcomes, which at the end of the day is what really matters. There are many examples here, including industry-leading 5G solutions in automation, transport, cloud, and security. But I'd just like to highlight one example, which is Orange. They deployed the Juniper Paragon transport automation solution to help them do telemetry-based traffic engineering optimization as they moved to 5G. The real business outcome for them was improvements in customer experience and service quality, as well as a sharp reduction in outages and faults. And they were recognized by winning the recent Light Reading Leading Lights Awards 2021 in the category of Outstanding Use Case in Service Provider, AI, and Automation. Thank you for tuning in to this session. I hope you have a better idea of the game-changing role of the RIC, which is the key to unlocking the true potential of O-RAN for 5G. Please reach out to your friends at Lintas and Juniper to ask how Juniper's best-in-class RIC platform can help you succeed in your RAN transformation journey, or how Juniper's leading 5G solutions in automation, transport, cloud, and security can help you solve your 5G business challenges. Have a great day and enjoy the rest of the Lintas Technology Solutions Day 2021.